Let x1, x2, xn be IID observations from a continuous population which is symmetric about theta, where theta is a true median. Here we want to test H naught theta equal to theta naught. This is a hypothesized median. Under H naught, define di which is equal to xi minus theta naught are symmetrically distributed about the median 0. Hence, positive and negative differences of the same absolute value have equal probabilities of occurrences. So, let us rank the absolute value of di as 1 to small n from the smallest to largest absolute deviance, absolute deviation, and later assigned the sign of di to its rank. Define t plus equal to sum of the ranks of the positive di and t minus equal to sum of the ranks of the negative di. If H naught is true, then we expect t plus to be approximately equal to t minus. Obviously, t plus plus t minus is nothing but a sum of n natural numbers, which is equal to n into n plus 1 by 2. Check. Now define delta I 1, it is the indicator function, equal to 1 if di greater than 0 for the ith smallest di 0 if di less than 0 for the ith smallest di mod di. Then this delta I are independently Bernoulli variables with probability delta I equal to 1 is equal to pi I, say I from 1 to small n. So, expectation of delta I is nothing but a pi I, and variance of delta I is nothing but a pi I into 1 minus pi I. Now, T plus is nothing but a sum over I from 1 to small n I delta I, and since T plus T minus is n into n plus 1 by 2, so T minus is equal to sum over I from 1 to small n sum over I from 1 to small n I 1 minus delta I. This is another indicator variable. We write it as sum over I from 1 to small n I delta I star. Check. This implies expectation T plus is equal to I from 1 to small n I expectation del I is equal to I from 1 to small n I pi I, and variance of T plus is equal to sum over I from 1 to small n I square variance of del I, since del i's are independent. So this is again equal to sum over I from 1 to small n I square pi I into 1 minus pi I. Under H naught, since I already mentioned that di, that is positive and negative differences of the same absolute value, have equal probabilities of occurrence under H naught. So under H naught, pi I equal to half. Pi I equal to half for I from 1 to small n. This implies expectation t plus equal to half into sum over I from 1 to n I is nothing but a n into n plus 1 by 2, this portion is n into n plus 1 by 2. Since this into half, so this equal to n into n plus 1 by 4. So expectation t plus equal to n into n plus 1 by 4, and this variance of t plus, this is equal to half into 1 minus half, this is 1 by 4, sum over I from 1 to I square, and this is equal to, we know, n into n plus 1 to n plus 1 by 6. So this is equal to n into n plus 1 to n plus 1 by 24. So we get we get expectation t plus is equal to n into n plus 1 by 4 and variance of t plus is equal to n into n plus 1 to n plus 1 by 24. When our alternative hypothesis is theta greater than theta naught, that is when we interested in right tail test, then we expect that t minus, we expect that that is when we interested in right tail test, that is theta greater than theta naught, then if the sample or we take a decision in favor of alternative hypothesis, it is better to say if we want to take a decision in favor of alternative hypothesis, that is theta greater than theta naught, that means your true median is greater than your hypothesized median, then your t minus should be as small as possible. So the critical region is less than equal to t minus less than equal to t alpha. This is a cutoff point. So the critical region is when theta greater than theta naught, then we reject h naught at level alpha. This is a pre-assigned value if t minus less than equal to t alpha. And when we interested in left tail test, and if we want to take a decision in favor of HA, that is your true median is less than equal to your hypothesized median, then you expect your t plus should be less than equal to T alpha star. So when we interested in left tail test, then we reject H naught theta equal to theta naught at level alpha if this, and when for both tail test then we reject H naught theta equal to theta naught at level alpha if T or rather you say it is better to say T. First of all, I write this thing because when we interested in both tail tests, then either your T plus should be less than equal to T alpha by 2 or your T minus should be less than equal to T alpha by 2. So if we combine these two part, then T, which is a minimum of T plus T minus, this less than equal to T alpha by 2. Exact distribution of T plus under H naught each delta I, small delta I, either take 0 or 1. So total number of possible cases or the sample space contains 2 to the power n points. Let capital AT be an event that T plus equal to small t. Then NAT is equal to total number of OAs of assigning the plus and minus signs to the ranks 1 to small n such that t plus equal to small t. So, the probability of AT is nothing but a small n AT by 2 to the power small n. For large n, that is greater than 25, under H naught, t plus minus n into n plus 1 by 4 divided by root over n into n plus 1 by 2n plus 1 divided by 24 asymptotically standard normal distribution. Now you can simplify this, then this is again 4t plus 1 minus n into n plus 1 by 2n n plus 1 2n plus 1 divided by 3. This is asymptotically normal 0 1. Note, this is note 1. Since we have assumed a continuous population there will be theoretically no zero or tight di in practice. In practice, zero differences are ignored, and small n is adjusted to include only non-zero differences. Each of the tight differences gets the average rank. Here also the level of level alpha may not be exactly attained owing to the discreteness of the test statistics. Note 2. The Wilcoxon test takes into account both the direction of differences both the directions of differences that is, we consider differences the magnitude as a rank. So differences here I mean ranks while the sign test considers only the directions only the direction of differences. Both the direction of only the differences, only the direction of differences. So it is better to write it here. Both the direction and differences. Direction means sign and differences mean rank. And sign test consider only direction of differences. This is the difference between sign test and Wilcoxon test. As such, the Wilcoxon test will be more efficient than the sign test. Note 3. Both tests both the tests are useful generally for the same type of problem but only the Wilcoxon test is suitable for a test of symmetry as well. The assumptions required are not very are not very restrictive for the sign test independence of observations and continuity at population median are required. And for the Wilcoxon test, continuity everywhere independence and symmetric are underlying assumption. This is your homework. For the Wilcoxon Signed-Rank test, show that the null distribution of T plus is symmetric about n into n plus 1 by 4 and that T plus and T minus are identically distributed. So I want to stop here. I will give practical example for this test in my next class and also discuss sign test and Wilcoxon Signed-Rank test for pair sample in my next class with and illustrating with an example. Till then, please stay with us. Thank you.